Hey YouTube, I'm Joe McGlynn. Welcome to my shop. We're picking up our work on the Studebaker. We left off last time having just made new anti-sway bar link ends. The next step is to get some axles in the rear end housing. I've never narrowed a rear end before, so when I set about doing this, my assumption was that I would need to have new axles made specifically to the size that I needed for the housing once it had been narrowed. And you can look online, and there's a lot of places that have stellar reputations that make new axles with whatever splines, whatever length, whatever bolt pattern, whatever kind of bearing, whatever stick out past the housing end you might need for your brakes. A million choices. And as I was bouncing around looking at those, I realized that it's also possible to buy cut-to-fit axles. And they're quite a bit cheaper than having axles made to order, $100 to $300 depending on how you look at it, cheaper than buying custom-made axles, which is good for my budget. So I ordered these from Speedway, and I went through a worksheet to figure out the dimensions that I needed. I started out by measuring the rear end housing after I had narrowed it for the overall width, flange to flange for the rear end housing. And then I installed the pumpkin, and I measured from each housing flange to the center of the drive shaft yoke. And that's my basic measurements. And then I looked up the brake kit that I'm using is an 11-inch drum brake kit from SoCal Speed Shop. They call it their police brake special. So that brake setup requires a 2.5-inch axle stick out from the housing flange to the outside of the axle flange. So with those basic measurements, I had enough to be able to order some cut-to-length axles that were long enough and could be cut short enough to meet my needs. Part of what I wanted to do with narrowing the axle, of course, is to tuck the tires in. And the other piece is I wanted to make sure that the housing, the center of the housing, was centered in the chassis. So the drive shaft will run at a slight angle. The yoke will be offset, but from the rear, the pumpkin, the differential itself will be centered side to side in the frame. So what I came up with is on the driver's side, I need to have an axle length from the outer face of the axle flange to the tip of the splines of 26 3/4 inches. And on the passenger side, it's 24.5 inches. So what I've got here, this is the cut-to-length axle. You can see that it's pre-drilled for press-in studs in a number of bolt patterns. So 4.5, 4 3/4, and 5 inches. So 5 on 4.5 inches, 5 on 4 3/4 inches, and 5 on 5. What I have on the front is 5 on 4 3/4. That's what I'm going to use here. So I've just made some witness marks for where I need to press the studs in later. We'll come back to that. So
what I've done is clamped a square to the axle. That way when I measure, I can get a straight measurement without having to jump around the bearings and bearing retainer. If I did that, I would be at an angle, and that would be an inaccurate measurement. So I can measure directly off the axle flange, make sure that I've got the exact measurement that I need, mark the axle, and then I'll get it set up for cutting.
Okay, I'm all set up here, ready to cut the first axle. So what I've done is just figured out a way to clamp the drill press vise down to my workbench. This is pretty solid, so I'll be able to loosen this and rotate it and just cut a little at a time as I go around. I'm going to suit up here to try to keep the grit and sparks off of my clothes and on my face. And let's see how this goes. that was not too bad. So I've got a nice plumb cut. There's a few little grinder marks on the edge. So what I'm going to do next is get a die grinder and smooth off this edge, bring it right down to my cut line, and then I'm going to carefully work around this and just grind a small bevel into the teeth of the gears so that when I go to engage it in the center section gears, it'll all be nice and clean. All right, I think that looks okay. I'm going to get a wire brush and clean out the splines, and I will grab a file and just lightly clean up the chamfer that I put on it, see how that works, and we'll be right back. And there we go. So one axle cut, I'll set up, cut the other one, and we'll be done with this piece. Okay, now that the axles are cut to the correct length, I need to drill the brake drums for the correct bolt pattern. I bolted the drums to my mill. My plan is to index off of the center hole and use a bolt circle calculator to figure out the XY dimensions for the 5 holes that I need to drill. Unfortunately, once I bolted these on, I was reminded that when we relocated across the country, we hired, honestly, the worst movers in the entire universe. An unbelievable amount of stuff went missing. I won't bore you with all the details, but it's almost funny at this point. So the mill arrived safe and sound. The handle for my Kurt vise arrived safe and sound. The vise itself is nowhere to be seen. Unfortunately, the handle for the knee on the mill is not here. No idea where that is. I'm sure it's somewhere in the country hanging out with the Kurt vise that I just bought and no longer own. So what I did is I drew up the special 7-tooth gear pattern or tooth pattern that is required for the knee handle on the Cincinnati Toolmaster mill. If it had been a Bridgeport, those are fairly easy to come by. I didn't see a replacement handle on eBay, so my best plan at this point is just to make a new one. So I have the tooth pattern cut here. I have a backup washer that will weld to that. I have a piece of DOM tubing that I will bore that will weld to that whole stack. I'll have a rudimentary handle that I can raise and lower the mill, and I can get back to the business of drilling out my brake drums. So I'm going to go do that, and I will be back.
So that worked out really well. Got all the parts welded together. Actually welded 3 nuts onto the end of it that are the same size as the handle for my missing Kurt vise. And I am back in business. Yay!
Well, I fit the coaxial indicator and I've got that set up. I'll turn it on in a second and you'll see that it's bouncing around about plus or minus 1/1000th of an inch as it rotates. So the point of this is to find the exact center of that. The bounce is just because of the surface finish on the hole that I'm picking up the center from. If I turn it by hand and I just check the 4 polar points on the hole, left, right, front, back, then I'm actually within 1/2,000th all the way around. So that's great. I've got the DRO zeroed out, and I have the XY coordinates for all 5 bolt holes for my 5 on 4 3/4 inch pattern. So I'll just turn on the mill so that you can see how the coaxial indicator works, and then I will grab a center drill and start drilling the holes on this first brake drum. You can see it's just bouncing from 20 to 22, so I'm real happy with that. Okay, on with the exciting part. We're ready to drill the holes. If you can see in the video, I've used a Sharpie to just roughly indicate where the 5 new holes need to be. And that's just as a sanity check as I traverse around. I want to make sure that I'm not drilling way off. I'd like to catch that before it's too late if that happens. So this is my first hole from 0, 0. I've moved the table out 2 3/8 inches and it's locked in at 0 in the X direction. So I'm ready. My plan is I'm going to center drill each hole. So I'll spot it and actually drill through with this beefy center drill. And then I'm going to drill through with a 9/16 inch bit. Now the wheel studs are 1/2 inch, but the holes are actually a bit over 9/16. So I'm going to use a 9/16 bit to drill the wheel stud holes, and then I will chamfer the edges from this side without moving the setup, and then I'll move on to the next hole. So I'll just move through this. We can fast forward the video later and find some nice tunes to listen to. So see you on the other side. All right, we're down to just assembly stuff. I won't belabor this. I have to put the wheel studs into the axle flanges. I have new Dorman wheel studs, and my plan is to use this small bearing and an old lug nut to just draw these on. It seems like that should work okay. I don't have a press here in the shop. That would sure be nice. So I have to do that. I need to drive the bearing race in, so I'll use a driver for that. I need to bolt on the retainer, slide the axle in, all of that stuff. So I'm just going to go for it and put the stuff together, and hopefully it all goes smoothly. Let me do it. And that's a wrap. So I've got the rear suspension together and the truck sitting back on wheels again. That's a great, great feeling. So there's always more to do. I still need to have gears in the rear section, drive shaft. There's a bit more welding. I want to box the underside of the frame rails through the kick-up. But this is all dialed in and it's in place. Everything clears and I'm very, very happy with it. I think it looks great. Big improvement over the rusty, kind of cobbled together mess that I was starting with. So next time, we're going to change our attention. We'll be doing less mechanical stuff and more fabrication and maybe even a bit of metal shaping. as I turn my attention to the inside of the cab here. So I've just connected up the steering, and it's now time to figure out the firewall recess, floorboards, toe boards, brake pedal, gas pedal, and I'm even going to build some custom hood hinges so that all of this stuff works and we start to move toward less of a shell and more of a custom truck. Until then, catch you guys next time.